Live. We are live.
I don't think we're live. Oh. Okay.
Hey guys, welcome to the final night of Crams. We are just going to wait a few minutes to let everyone in. All right, we are going to start getting started. So welcome to the final night of Crams. Tomorrow's your guys' AP exam. You guys are all going to do great. It's going to be amazing. And today we're going to be doing some review and cramming and getting all the final things that you'll need to remember for your exam tomorrow. Let's move on. So here's the cram schedule for AP Physics. So we did units 1 through 2 on May 6th, 3 4th on May 7th, 5 through 6 on May 8th, and our unit wrap-up was on May 9th. And then May 10th was today is our grand finale. So here are all of our student hosts. I'm Anastasia, and introducing our next hosts.
Hello, I'm Juliana. I'll be doing some MCQs and FRQs today with you guys.
Hi everyone, I'll be covering the experimental FRQs today and just any final tips.
Hey guys, I will be going over a momentum quiz and a momentum FRQ today.
All right, moving on now. Follow Think Fiveable on social. Moving on, please. And today's our 95 practice time. Hey, Zeke. Next slide, please. So we're going to do types of MCQ questions today. We are going to be going over types of FRQ questions. We are going to be doing a lot of practice time today, and then we are going to be doing a really big Q&A so you guys can answer so you guys can ask any last minute questions and we're going to answer them, and then we're going to have our wrap up. Next slide, please. So how to make make the most out of a cram finale. Make sure you guys write down some notes so they keep you active, but don't try and overdo it. Notes are supposed to be served as reminders, mnemonics, questions, and a study to-do list. And then you guys can go back into the Cram Hub to look at all of the slides, the review packet, and all the replays for you guys. You guys can follow along. And then we have the group chat on Crowdcast, and it's for sharing tips and tricks and to participate when we ask our questions. We also have like a poll section, so whenever we're doing practice MCQs, you guys can go and vote in the polls. And we also have a Q&A tab, and it's for asking questions and checking the comments for answers. We will also be taking some breaks, and you guys can always access the replay right after the event is over. Next slide, please. The community agreement. So make sure you guys be supportive. Let's lift each other up. Let's be patient. Today's our last night, so we're going to try and get to everything today. And also be kind to everyone. We're all real people. Next slide, please. You can win $100 by sharing your Cram experiences. You can post about your Cram finale experience on TikTok or Instagram, and all the information is right here. So you guys can go and do that for a possibility to win $100. Next slide, please. So we're going to be starting off with the MCQ basics today. Next slide, please. So the MCQ tips. They are to make sure to use and understand your formula sheet, but do not rely on your formula sheet, because the more that you practice, the more natural it should come. But the formula sheet should be kind of like oh, okay, I need to remember this. I need to go back and do that, and just it's for remembering more rather than fully relying on it. Using process of elimination helps so much. Like every single test I've been taking, process of elimination has got me better scores. And next one is to identify whether you are dealing with a force, kinematic, rotational, momentum, or energy question first. That is one of the biggest things, because you can just start off with going to like a whole section in your brain with, okay, this is everything I know about force. This is everything I know about kinematics, rotational, whatever. That helps a lot too. And then do not try and spend more time than you should on a question, because you guys have a time limit and it's not the nicest time limit. So don't spend more than 2 minutes on one question. Make sure to read each question very carefully, because there can be underlying information that you might not know about, or extra information that they may be giving you that you might not even need. So it might be trying to throw you off or try to trick you. So you always have to read it super carefully. Draw a graph or free body diagram for each question. So with AP Physics 1, free body diagrams and graphs are your go-to. So always make sure to draw those. And lastly, make sure you are bubbling in the correct line on your Scantron sheet. I know I've messed up on my Scantron before. Everyone has at possibly some point. So make sure you guys are always bubbling in your correct Scantrons. And also do not forget that 5 questions on the multiple choice are multi-select. So they're going to be at the bottom of the little sheet that you guys are going to be given, and they are going to be multi-select. So you need to bubble in 2 answers and use a started line. So there's going to be a section on the sheet, so you guys can bubble in the multi-select ones. All right, next slide. Let's practice multiple choice. So I'm going to be handing it off to Tammy now.
All right, guys, who is ready for some multiple choice? Yes. Okay, let's move to the next slide. We are going to go over like a momentum MC and a simple harmonic one that we didn't get to on night 3. So let's do it. So here's our question. Yeah, hey guys. So here's our question. Initially at rest, on an ice rink, two skaters are present. One skater is a teenager with mass M, while the other skater is a child with mass 1/3 of the teenager's mass. After pushing on each other, the child skater moves away with a speed of Vc. The teenager moves away with a speed of Vt. What is the speed of the teen immediately after the push? Okay, guys. So take a minute. I'll make a poll and try to solve the problem. All right. I am so happy with the answers and the poll and the chat. So yeah, great job. Let's move through the solutions for some of us who are a little confused. So like most of the people in the chat said, we are using conservation of momentum. Some things to remember here is recall that in the beginning of the question, they tell us that the skaters are initially at rest, meaning that the momentum initially is 0, right? So we are calculating for the final the final velocity or final speed of the teenager. So we can basically equate the final momentum to 0, because remember, initial momentum is 0. And then we basically just expand that momentum equation to the child and the teenager in line 2. In line 3, we isolate the momentum of the teenager. And in line 4, we further isolate the velocity of the teenager. The reason why there's a negative on the momentum of the child is because we've subtracted the momentum of the child from both sides. And once we do that, all we do is we plug and chug the mass over 3 for the child's mass, and we divide that from the mass of the teen. Both of the masses cancel out, and we get negative the velocity of the child over 3. But remember, we're asked for speed, which is the absolute value of velocity, and it's always going to be positive. So the answer is A, like everybody said. Great job. And yeah, honestly, no, not even College Board is going to do this to you. I was just seeing if y'all were reading the question properly, and you did. Good job. So yes, any questions? Plug in, yeah. Conservation of momentum. Okay. Yeah. Okay, it looks like nobody has. Yeah. Yeah. Okay, right. Ari, you're right. But I haven't seen it before. I haven't seen them do this negative thing. I don't think they're that mean. But yeah. Okay. Okay. I mean, you're right. College Board is unpredictable. But yeah, okay. So you guys have answered this question really well. So let's move to the next multi-select harmonic question. All right. This should be a cakewalk for you guys. We'll do chat for this one. Thanks for reminding me, but it's multi-select. So remember, there are 2 answers. Timothy, I will go over that answer right after this question. Thank you for asking. Okay. Yes. Everybody is saying the right answer here. A and C. Yes. Great job. Let's get those transitions in. Yeah. So basically, our question is: a mass is suspended from a vertical spring attached to a support. Which of the following significantly affects the period of oscillation of the system? So our formula for period for a spring mass system is 2 pi times the square root of m over k. So basically, to know what significantly affects the period, it's going to be those 2 variables. So mass and the spring constant. And that is exactly what you guys said. So A and C. Great job. Can we go back to that slide? If nobody has any questions on this, let me just answer Timothy's question. Oh. Okay. So Timothy, the reason why in step 2 we see 0 is because remember that initially, and that the first couple of words in the question say initially at rest on the ice rink, saying that the skaters are initially at rest. So that means their momentum is 0 initially, because remember, momentum is m times v, and v is velocity. And if they're initially at rest on the ice, that means velocity is 0. And that's why we can say that momentum initial is 0. And we can equate the final momentum to 0. Does that make sense? Yes, Anshu, there are a couple of slides today. All right, okay. Looks like that made sense, and I don't see any more questions. So let's move on to our next thing. This is just one of those momentum quizzes. This is just because we weren't able to recover that recording from night 3. So this is just a review of momentum. It's pretty simple. We'll go over it if you guys have any questions. So yeah, please scan the QR code once it comes up. And yeah, a quiz, like, you know, one of those. Yes, we are going over torque right after, Ruthie. Yeah, it's one of these quizzes, S&M. Yeah. All right, so get on there. Okay, guys, apparently the music starts once you start the quiz, so let's try that. Okay, I can hear it now. Okay. Okay, guys, let's go over this. Change in momentum equals 95% of you said impulse, which is the right answer. That's just the formula. So, delta P equals J, which is the symbol of impulse. So yeah, keep that in mind. Yeah, it seems like most of you got it. I think just some of you, just maybe the wording tripped you up. So let's move on. Oh, whoops. Okay. Let's move to the next question though. Muted. Okay, this was just one of those other questions that, it's just momentum is defined as mass times velocity. 94 of us said that. Yeah, I think it makes sense. The angular velocity of an object times the radius, no. The force of an object times the distance, no. Okay, so I think none of us has questions on this. Yeah, I know. I was wondering that too. How does 92 out of 86 people answer? I have no idea. Just glitching. Okay, let's move on. Yeah, these are just, once again, questions for understanding. Yeah. So let's move on. Ooh. Okay. Dang, where did that music go? Okay, guys, let me figure this out. Okay. All right, looks like everybody answered this. Yep, another simple problem. Impulse is just force times time. And we're asked for how many seconds did the force act on the object. That's just going to be impulse divided by force, which is 2 seconds. So yeah, everybody got this one, I think. That's great. I'm not sure where the 1% are coming from, but but ask if you have any questions. All right, next. Okay, KGMS, yes, that is correct. It looks like some people got tripped up on kgm over s squared. That's pretty important to keep in mind. It's just KGMS. That is the units for momentum. KGMS, just say it to yourself. Yeah, because remember, it's the formula for momentum is mass times velocity. So mass is usually in kg and velocity is in meters per second. So yeah, KGMS, it makes sense. And also, we hear you on the request for like tension and pulley problems. Zeke is working on getting all of you guys an FRQ, or Week is working on getting y'all an FRQ. So yeah, so this is just quiz for understanding. So let's move on because it seems like all of us have got this one. Oops, sorry. Okay, thank you guys. So remember, the units for impulse is Newton seconds. And it's also kgms actually. So remember the units for impulse and momentum is the same. It's kgms, but it's not kgms squared. So some people are tripped up on that. B, that's just the symbol. The J is the symbol, just like the P is the symbol for momentum. The J is the symbol for impulse. So yes, remember Newton seconds. Also kgms works. Yeah. Any other questions? It's just something you need to keep in your mind. So, yeah, exactly. Okay. Yep. Yeah, y'all listen to Juliana and Shagun. Yeah. LOL, I'm not sure if you're asking about this particular question, but no, it's not Newtons over seconds, it's Newton seconds. Yeah, like just like Brock said, Newton seconds. All right. Let's move to the next question. And please ask if you have any questions. We'll get to it. Sorry, guys, this is a lot to handle. I don't know how Juliana does it. But yeah, I hope all of you guys can hear me. Yeah. I just wanted to answer Arnav's question real quick. He asked, so momentum was kgms and impulse is Newton seconds. That's correct. Impulse can also, the units for impulse can also be kg times meters over seconds. Just to make sure everybody knows that. Yep, epic failure. You are getting those. We're just going to go through. So we have like 4 more questions left out of this momentum quiz. And we are, we're going to go over a torque quiz after that. And we're going to be getting those tension FRQs. All right, let's move on to the next question. muted again. So I'm glad 85% of us got this one. The question is, kinetic energy is conserved in a dash collision, and the answer is elastic collision. I really tried to bring this point home on night 3, so I think all of us got it now. Remember that kinetic energy is conserved in an elastic collision, and it's not conserved in an inelastic collision, and that is the main difference between the two. So great job here. Okay, I just want to answer Sam's question real quick. I'm having trouble distinguishing the difference between elastic, inelastic, and perfectly inelastic. So elastic and inelastic, it's like I told you, it has nothing to do with momentum, because we're going to assume that momentum is conserved whenever there's a closed system. The difference between the two is when kinetic energy is conserved. So for elastic collisions, kinetic energy is conserved, meaning the kinetic energy initially is equal to the kinetic energy final. Whereas in an inelastic collision, the kinetic energy initial is not equal to the kinetic energy final. That extra energy goes off as like heat or something like that. A perfectly inelastic collision, I believe, is when like it actually like sticks together. The two cards like actually stick together, but I might be wrong on that. So yes. Okay. Perfect. No bounds. Exactly. Objects stick to each other. So I hope that made sense. How do you know what direction the masses will slide in an inelastic collision? What directions mass will slide? It will tell you in the problem. It should. Okay. So these are the questions pertaining to momentum. So let's quickly move on to the next problems and finish this quiz up so we can move on. Okay, next question. Okay, let's talk about this one. In a closed system, the center of mass moves, and 75% of us said at a constant velocity. Great job. This is something we also went over on night 3, that in a closed system, the center of mass always moves in a constant velocity. And it's not with constant acceleration, it's with constant velocity. I think that's just something you have to keep in mind. And yeah. Okay, let's move on to the next question. I don't see any questions in the chat. All right, guys. I'm just going to move on because we have a lot of content to go through today. But yeah, I think most of us got 80% of us got the right answer. Great job. Let me just read the problem and quickly go over it. So it tells us that a 2 kg black ball moving at 5.2 meters per second collides with a 13 kilogram white ball at rest, causing the two to move forward as one. Find the velocity of the ball after the collision. Okay, so the key here is to identify that the balls come together and move forward as one. So there's only one final velocity, and we're asked to find that final velocity. So we could easily do this. All we have to do is this is conservation of momentum once again. We multiply 2 times 5.2 and add that to 13 times 0, because remember the white ball is at rest. And then for momentum final, basically we just want to add the weights of the two balls. So 2 and 13 to give us 15 kg. And after that, we just isolate velocity final to get an answer of 0.693 meters per second. Do we have any questions on that? Okay, I don't think so. Let's move on to our final question for this quiz. It's a little calculative, but yeah, let's move on. Okay. Sorry, 10 of you couldn't answer the question, but our answer is D, negative 1/2 meters per second. 17% of us got -2. I think that's just an algebra mistake. But let's quickly go over it. For our equation, we have that initially a cart A of 4 kg moves at 2 meters per second, so that's 4 times 2. And cart B with a mass of 2 kg. Oh, and cart B is at rest, meaning the momentum for cart B is at 0. You're right, Sahiti, you're right. These are just questions that I just got off of Fiveable, so we'll have to blame them. But keep that in mind, speed can't be negative. Speed means positive. So we're just going to blame them on this one. But continuing with the problem, we have our initial momentum of cart A is 4 times 2, which is 8. And cart B, our initial momentum is 0. And after that, we are told that cart B continues to the right with 5 meters per second, meaning cart B's final momentum is 2 times 5, which is 10. But cart A rebounds and begins to move to the left, and left means negative. Let's remember that. So we're just asked to find the final velocity of cart A. We already know its mass. So basically what we do is we isolate the final velocity of cart A, and we find that final moment or final velocity. What I got was 8 minus 10 over 4, and that gave me -1/2. But since it's asking for speed, like y'all said, the answer should be 1/2. Okay. I think so. Speed is always positive. Yes, Emily, you're correct. Speed is the absolute value of velocity. Okay. So great job on this quiz, guys. We have so much more to get through, so I'm going to go ahead and end this quiz. Ask any questions in the Q&A. If you have any questions, I will get to you. Now let's move on to a torque quiz. Okay.
Hello guys, we'll be doing a practice quiz on torque right now, so I will put up the link for you. that people are overcomplicating this question. So it's actually a lot simpler than what you think, and that's all the hints I can give right now. Okay, I think most people answered, so let's reveal. And the correct answer, which around 60% of you got, was 375 Newton. So this problem is not actually as difficult as you think it is. There's actually no torque involved. So the first rule about torque problems is you have to figure out when it's a torque problem. And the clue is that a torque problem will pretty much always have a pivot, and they'll give you a distance from the pivot. If it's a seesaw, then it might have a fulcrum. But here, there's just going to be two upward forces from the two chains, the tension in the chains, and two downward forces, one from the weight of the board itself and one from the person. So to do this, you just do downwards forces minus upward forces to make the two equal. So that's 125 plus 500 minus 250, which is 375. It doesn't really matter where the person is sitting in this problem because we're assuming that it's in equilibrium and the weight should cancel out. All right. Does anyone have any questions? I'm not seeing any, so let's move on. Ria, we could throw in a couple problems later if we have the time. All right, here's an actual torque problem. Okay, most people answered, so let's review. All right. The correct answer, which most people got right, I think once you figured out which equation to use, was 0.43 Newton meters. So here, torque is moment of inertia times angular acceleration. And we know that angular acceleration is the change in angular velocity over time. So we see here that the change in rotational velocity is 10 to 5 to 15 radians per second in 10 seconds. So that's 15 minus 10, which is 5 over 10 seconds, or 0.5. And then you just multiply that by moment of inertia, which is 0.85, to get like 0.425, which is rounded to 0.43 Newton meters. All right, does anyone have any questions? Giant, for rounding, I would recommend thousands because it's always better to have a little more precision with these, but hundreds should be fine too. It depends on how many significant figures your problem has, but it's not too much a big deal for AP Physics. No, you don't have to use angular momentum. All right. Okay, we can run through that again. So torque is, let me scroll up to have the problem. There we go. Torque is moment of inertia times angular acceleration. And we're going to be given the moment of inertia right here. So angular acceleration is change in rotational velocity over time. So the change is 15 minus 10, which is 5, and the time is 10 seconds. So 5 over 10 is 1/2. So 1/2 times 0.85 is 0.425, which is closest to 0.43 Newton meters. All right, I'll move on to the next problem. Yes, AP class study, it's exactly like that. So if you forget like what the torque equation is or any angular equation, you can like figure out which equation is the linear equivalent and kind of substitute the values in. But make sure to give your answers in the correct units. Okay, I think most people have answered, so I'm just going to reveal. And the correct answer, which most people got, was 0.75 Newton meters. And here, torque is equal to moment of inertia times angular acceleration, and you're given both values, so it's just 0.25 kilograms meter squared times 3 radians over second squared, and you just get 0.75 Newton meters. All right, and then next question. Okay, most people answered, so I'm revealing. Okay, so the correct answer is the slope of the graph. So here it says that a student wants to determine the moment of inertia of an object, and they plan on sketching a graph with torque on the y-axis and angular acceleration on the x-axis. How can they use the graph to find the moment of inertia? Okay, so here torque equals moment of inertia times angular acceleration. So if you're solving for a moment of inertia, that means I equals t over a. And since t is on the y-axis and a is on the x-axis, that also means that I equals, can anyone hear me? Okay, Matthew, try leaving and going back in Crowdcast. That might work for you. Okay, so moment of inertia is equal to torque divided by angular acceleration. And torque is on the y-axis and angular acceleration is on the x-axis. So that means that moment of inertia is also equal to change in y over change in x, which is also equal to the slope of the graph. Divide by the slope of the graph. No, I don't think you would ever need to do. It's usually multiplying the area under or finding the slope. Okay, next question. Okay, most people have answered, so I guess we're moving on. Reveal answer. All right, so the answer is 40 kilogram meters per second. So the question is asking a constant force of 8 newtons is applied tangentially to a disk with a diameter of 100 centimeters for 10 seconds. What is the change in angular momentum after 10 seconds? So here we're looking at change in angular momentum. So that is going to be equal to torque times time. So we know the time is 10 seconds because it's given to us. So we have to find the torque. So you might be tempted just to use the 8 newtons, but you have to remember that that is not the torque. It's actually the force. And torque is equal to the radius times the force, and it has to be the perpendicular part of the force. The good thing here is that we're told that the force is applied tangentially to the disk, so all of the force is perpendicular to the center of gravity. And then it says here that the diameter is 100 centimeters or 1 meter. So the radius would be half a meter or 0.5 meters. So 8 times 0.5 would be 4. And then multiplying by the time, 10 seconds, would equal 40 kilogram meters per second. Remember here that you're not going to use centimeters. You're going to use meters because your final answer is given in meters, not centimeters. All right. Does anyone have any questions for this problem? Oh, it's 100 centimeters, so it's 1 meter. So the radius is 50 centimeters, which is half a meter. And it has to be done in meters because that's what your final answer has to be given in, because that's the SI unit. T equals IA isn't on the formula sheet, right? I don't actually think it's on the formula sheet. I think they give you the other equation for torque, which is RF. So you have to memorize that one. What was the whole formula used for this problem? For this problem, it was force times radius equals torque, and then torque times time equals change in angular momentum. Yep, you have to convert. Why is it 40? Okay, so the torque is 8 newtons times half a meter because the radius is 50 centimeters or half a meter. So that would equal 4 for the torque. And then multiplying that by 10 seconds for the time gives you 40. Yeah, you have to be careful with units. College Board might do this to try to trick you. Yes, any centimeter questions do need to be converted because meters are the SI units. There's no sin theta because it's tangential because it's 90 degrees. So technically sin theta would equal 1. All right. The torque time equation is torque times time equals change in angular momentum. It's equal to the linear equation, which was force times time equals impulse. Tangent means 90 degrees, yes. Okay, I don't think there are any more questions for this problem, so let's move on. Okay, so most people answered, so I'm going to reveal. Okay, so the correct answer is that the thin spherical shell will have a greater moment of inertia. And so this concept goes back to the figure skater, and the figure skater moves slower with her arms out and faster with her arms in. And it's the idea that the farther mass is from the center of gravity or the center of mass, the higher moment of inertia will be, because it's harder for a torque to make the object roll. So the thin spherical shell has more mass on the outside, because all of the same mass is concentrated on the very edge of the sphere instead of like partially in the middle. So the shell has more moment of inertia. Oh, and by the way, we are taking a break after this quiz. They don't give you the equations unless you need it for that problem specifically. You don't need to know the equations. The speed would just be like angular velocity. Inertia is like resisting that movement. The center of mass is in the middle, but the actual mass is on the outside. With the same torque, the shell would have a lower acceleration and velocity. I equals mr squared is for only a point mass. Different shapes have different equations. Basically, the farther away most of the mass is, the harder it is to roll and the higher the moment of inertia is. So in the solid sphere, there's like a bunch of mass in the middle, but in the spherical shell, all of it is on the outside. Okay, I think most of those questions are now answered, so let's move on. Okay, a lot of people want to move on, so I'm going to reveal the answer. And the correct answer is B. And I'm seeing a lot of people ask for a whiteboard, so I'll go pop that up. Okay, I think everyone can see this, correct? Can everyone see the whiteboard? All right, everyone can see it. So here, work equals force times distance. So we're going to say that the rotational work equals torque times angular displacement. So remember that pretty much any linear equation works if you plug in the corresponding values for like the rotational equivalents. So force is equivalent to torque and distance is equivalent to angular like displacement or distance. So here you can see that the distance is 1.5 revolutions, which is 1.5 times 2 pi radians. And if you plug that in a calculator, that's about 9, I think. I'll just say it's about 9, guesstimate. Okay, so torque we know is equal to 15 initially, and the distance is about 9. So if we multiply these two together, we should get work, which is, this number is approximately equal to 190 plus 45, 135. So the closest answer to that would be B. If you actually multiply 2 pi, you would probably get a rounding to 141, but I just kind of did it in my head. If you're dealing in trig, yes, you do degrees, but if you're talking about angular velocity or displacement or acceleration, those need to be in radians. So it depends on what you're doing. If it's something angular, I recommend you use radians. And if it's something to do with like a free body diagram and components of forces, you're probably going to use degrees. I don't think there is a symbol for rotational work. I think you just have to specify this. How did I get 9? Okay, 2 pi is like 2 times 3.14. So I just made that around equal to 6. So 6 times 1.5 is 6 plus 3, which equals 9. What are the units for revolutions then? 1 revolution is 2 pi radians, because 1 revolution is going all the way around the circle, which is 2 pi. Yeah, I just estimated because I didn't want to pull out the calculator and waste your time. Okay, does anyone have any other questions on this? Okay, I'm not seeing any, so let's move on to the next problem. Oh, should it be 2 pi times the radius? That would be, I think, if you're finding the angle, but we're finding the distance. 1 revolution is 2 pi, so instead of a revolution, I substituted in 2 pi radians. Sophie, it's torque times angular displacement, because work equals force, which is analogous to torque, and distance is analogous to angular displacement. Sorry, Ben, I can't come to the test with you guys. I think, Dia, it's something you should know, but it's just a general math thing. It's just basically the circumference of a circle. It might even be on the first page. All right, I'm moving on to the next question. Nice. Okay guys, just clarifying, this is a slightly confusing question. So when it says the student doubles the velocity, I'm pretty sure they are referring to the angular velocity. And I don't think this is a centripetal acceleration problem. It's poorly worded, but I don't think that's what they're getting at. Okay, I will reveal the answer in hopefully explain this badly worded problem. And the answer is quadruples. All right. Actually, no, I need a good explanation for this one. Wait, let me figure it out quickly. Oh, no, now I figured it out. Sorry, guys. Apparently it was a centripetal acceleration problem, which is kind of weird. This one was very badly worded, but I'll do it on a whiteboard for you guys. All right, so acceleration equals v squared over r. Can everyone see this? Yeah, everyone can see this. I thought it wasn't. It confused me because they didn't tell me anything about uniform circular motion, but I was looking at the wrong thing. Sorry, guys. I think I misled you in the beginning. Okay, people who went with their gut and said that it was a centripetal acceleration problem ended up being right. Okay, so if v is doubled, that would make this equals 4v squared over r. Okay, so that means if v is doubled, the overall acceleration is multiplied by 4. So to counteract that and keep acceleration the same, since the numerator is multiplied by 4, we also have to multiply the denominator by 4. So put a 4 here, which means that the radius quadruples. Okay, does anyone have any other questions? Okay, I don't see any, so I'm going to switch back to the quiz. Okay, so the answer, which pretty much everyone got, is pulling your arms as close to your body as possible, because this decreases your overall radius and basically decreases your moment of inertia. And since angular momentum is conserved, that means your rotational velocity has to increase. And that is the end of our twerk quiz. And right now we will be taking a 5-minute break before moving on to FRQs and then Q&A time. All right, so see you in 5 minutes.
All right, guys, try to circle back since we do want some time for the experimental. So yes, just come back in. Let me know if you guys have come back from the break. Wow, we have like 55 minutes left. All right. Okay. Let's do some FRQ practice. Well, first we'll go over some experimentals. Yeah, all right, so the experimental FRQs. Whoop, whoop. All right, next slide, please. Okay, so essentially for the experimentals, here, contradictory to my other words, you guys kind of should memorize this just like in a general sense, but the main thing you want to know for the experimentals is variable equipment. Whenever you describe any equipment, you want to say what kind of variable you're using with. So for time, kind of obvious, if you're using any stopwatch or timer, please don't say like my phone's like clock app or something. Generally use the word stopwatch. Timer works too, but stopwatch is better. Yeah, no. Stopwatch, not timer. Because timer, you could say like, oh, I'm like counting down seconds, but stopwatch is just easier. So use stopwatch. Distance and position, you can use a meter stick, rulers, depending on the distance you're measuring. And please make sure that a lot of experiments like trip you up sometimes, they say like what displacement or distance. Either way, you're still using the same equipment. Just make sure you don't get tripped up whether it's which one you're solving for. Remember, displacement is just like your final position minus your initial position, but distance is like the entire thing you travel. Just remember that in mind. For longer distances, yeah, you would use a measuring tape. Again, it just depends on the context of your problem. For angles, use protractors. That's pretty self-explanatory. Masses, you would use a scale or a balance. You could say either one. I personally use a balance, but actually no, sorry. I personally use a scale for our physics classroom labs, but people use scales as well. Velocity and speed. Okay, here you're either going to use a photogate, speedometer, or a motion detector. Don't worry, I'll get to everything very soon if you've never heard these words before. And for force, you could use either like a force probe or a spring scale. Oh wait, I'm paused. Hello? Can you guys hear me?
Yep, you're good.
Oh, okay. My bad. Yeah, my computer's been like Xing me out for the past like 10 times, so I don't know what's going on. But yeah, I'll go over into what photogates are and everything. All right, next slide, please. Okay, so what is a photogate? So it's literally like by definition, like I was trying so hard to find like a different definition, but all I could literally find was like gate. So a photogate is literally a type of gate that has like a laser. So essentially, if you can see on the two images that I have, you're going to have I don't know if I've seen people use one photogate before, but usually you use two photogates. And essentially when it has a photogate has a laser in it. So when a car goes through the laser, the photogate starts a timer. And then when the car leaves the gate, it ends a timer. So it essentially utilizes the equation that velocity is distance over time elapsed. So what you would do is that you get to know how much distance your photogates are between, and then you know the time elapsed due to the laser that the photogate has, right? So from there, you can derive velocity because it's distance between your photogates over the time it enters the two photogates. So as you can see from those two images, I have the car hasn't entered the photogate yet, but there's two photogates here. And you have a start timer, end timer. It goes to that first timer, and then it goes out the second timer. All right. Next slide, please. Yeah, gate of light. I like that. Okay, so now what's a motion detector? So yeah, motion detector, motion sensor, same thing. It's actually based on sonar technology, which is pretty cool because it emits any ultrasonic sounds. So essentially, it sends out any sound waves that bounce off the objects it's nearby, and then those waves bounce back to that motion detector in order to give an accurate description of how far that object traveled. So it's actually used in most cases for collisions. So if you can see on that kind of like, what's that called? That diagram I have below. You're gonna have two motion sensors on the side. Well, you can't see my hands on the sides, and you have two carts, right? So when those two carts collide, the motion sensor on each side of the cart that detects how far that your cart has moved. So based upon in that collision, right? So based upon that, the motion detector is usually connected to a computer, and that computer actually graphs out that the change in position for your cart, and then it also has a graph for your velocity. So usually you would say that, okay, I can use a motion detector to either calculate the distance traveled and then divide by the time, or you can simply just look at that velocity versus time graph that the motion detector uses. Yeah, the slope of velocity of the acceleration graph is acceleration. That's actually better. Usually I think motion detectors can also graph acceleration, but they don't want to see that. They don't want you. It's usually used for velocity or distance. Okay, next slide, please. All right, so now what is a force probe? So this is like the only what I would for the experimentals, like stopwatch, meter stick, photo gate, motion sensor, those are all like transitive. You can use them one or the other, it doesn't matter. You still get points on what you use to calculate the velocity or the time. But a force probe is the only thing that measures force. So you got to know how this works, because essentially a force probe is a technology and it has like a hook. So basically like this big black box with like a hook. And then you attach your force probe to your object. So when you pull on that probe, it detects the amount of push or pull that you used. So that is also connected to a computer. So your amount that you pull is actually equal to the force that's applied to the object. All right. Next slide, please. Yeah, I'm just going over these equipment so you know what it is, because a lot of people just say, oh, spring scale motion detector, and they don't know how it's applied. And then finally, a spring scale is anything that measures in Newton. So it's a spring scale, but it measures a force. Just remember that on one side, and then there's a grams on the other side. So we're only concerned about that Newton side. So it's another hook that's connected to this kind of plunger, and you attach that hook onto your object, and then you pull from that spring scale. So as you pull, well, it's a typo. As you pull on that object, the needle of that plunger moves down. So then it will usually stop at that mark of how much force you pulled. However, the only thing that's a drawback, I would say, for the spring scale is that a spring scale can come in many different forms. So they have like a max capacity, right? So for our physics lab, we have like 400 Newton spring scales and like 50 Newton spring scales. So if the needle comes all the way down, you actually max out on the force for that spring scale. So essentially, you just want to make sure that you have an estimate of your mass and the acceleration before your experiment, so you're using the right spring scale. Honestly, just use the force probe, but it's nice to know. All right, next slide, please. Yeah, if there's friction, does the force probe still only show the force of the pull? That's a really good question. The force probe will only account for the force that the applied force that like you pushed onto that object. All right, so this is just an example of how the spring scale works. If you can see on the side, they're like pulling, the plunger is determining how much force you move for the rock. All right, next slide, please. This measures force, Dia. All right, so this is just nice to have. I thought it was pretty cool, but gyroscopes or accelerometers, essentially I don't think you're ever going to use this, but essentially whenever your velocity is changing rapidly and you can't like determine the velocity just based on the slope, then you can use an accelerometer, which is essentially it just detects how much acceleration an object has. So yeah, it's nice to know. We'll see where you can apply it. Next slide. All right, so now what do you have to do in the experimental FRQ? So essentially what you're testing you on is that you can look at raw data or raw explanations, and then you can determine how you can rearrange that data in order to prove the conceptual properties of physics. I don't know why they say it like that. So the key idea really here is that you need to be able to recognize relationships between variables and in your data. So sometimes you aren't provided with the data, like I said, but you're asked on what your data will need in order to prove your physics concepts. So then you need to design an experiment in order to lay out the steps of not how you're doing a mathematical calculation, but how any student, if they replicate your experiment, can get those values to calculate and how. So how are they going to be calculating velocity? How are they going to calculate force? You got to tell them. And then finally, you need to defend your answers using logical reasoning. If you're calculating slope, you just need to show the rise or run formula and you're just like subtracting 2 points. You don't need to be like, oh, I'm minusing like 5 minus 1. All right, next slide, please. All right, so concrete tips here is that please do not write like 5 paragraphs per step. No one's gonna read if like you have to bend down, pick up like the wire or whatever. You gotta like whenever you're deciding your lab setup and your experimental design, you want to make sure that you can actually use your materials and determine your quantities. Don't go overboard with like, you know, how you're supposed to calculate any mathematical expressions. And then again, don't waste your time in saying like gather your lab equipment or like something that's not, you know, needed. No extraneous words. College Board will know if you're just trying to fill up space. So just get to the point. The shorter, the better. All right, next slide, please. All right, so how do you essentially start up your procedure? The first thing is that you have to use verbs in every single line of your thing. Don't say like, oh, the recorder will do this. Just say measure to distance or start the timer. Use verbs in the beginning of every sentence. Start by describing how you're gonna set up very briefly, just like make sure you like hold the string taut or make sure you don't let go of the mass before you start. And you always want to go quantity by quantity. So don't try to like say how you're going to calculate time, distance, velocity all in one step. That's too much and you're just wasting your points. So you want to be able to use each step to describe how you're finding either another variable, changing a variable, or how to experimentally calculate that variable. So the main thing you should get out of this is equipment, variable. How are you going to find out that variable? How are you going to use your equipment in order to find out that velocity? Yeah, you will lose points in your calculations if you don't have units. All right, next slide, please. Oh, no, sorry. Yeah, your calculations are fine. Your answer, you should have units. My bad, I read that wrong. All right, so what's the deal with graphs here? You're gonna get a lot of graphs, like a lot on the AP Physics 1 exam. So everyone please type, I will label the title and axes of my graphs with units in the chat right now. This should be for any experimental, really anything that that should be like your mantra for the experimental, that you gotta label your axes, or they take like 3, it's like, I'm telling you, it's like 1 point for labeling your graph, 1 point for labeling the y-axis, and 1 point labeling the x-axis. There we go. All right, so you want to plot your data carefully, double check that your points are aligned, your spacing accurate. Usually it's a good rule of thumb. There we go. I like that. That like you want to use at least more than half of the graph that's provided to you. So maybe your wow. All right. So maybe you want your x-axis to be in like in 5s, 10s, 15s, and your y-axis, they don't have to be in the same scale. So as long as you fill up your space, you're good. So your y-axis could be like what, 20, 40, 60, whatever it is, just make sure you're filling up more than half of your graph. They check for that. Whenever you're asked for a best fit line, you want to use a straight edge. You're allowed rulers. I actually forgot that in my physics C exam, and like midway I had to be like, oh, can I have a ruler? So essentially, whenever you're doing this, you want to align your first and your last point together and just draw a line through there. And generally, it's a good rule of thumb that you have approximately the same number of points above your line as you have below your line. All right, next slide, please. All right, so again, you guys were waiting for this. I saw this in the chat several times, but yes. Whenever it says you're gonna see any experimental for FRQ that includes steps necessary to reduce experimental uncertainty. That means you're gonna always write that you have to repeat the experiment to perform multiple trials. That's literally a free point. Please take it. You also need to say like how you're going to be repeating your experiment. Like, are you going to be finding the average value of the velocity, or are you going to be making adjustments to the data? Like, are you going to be changing the distance, or are you going to be changing the mass, the hanging mass? And then yeah, do not add any like extraneous measurements to your repeats. Don't be like in the repeat, oh, by the way, I add in like a hanging mass. I know it's obvious, but like when you're like trying to like do your FRQs, just make sure you're just being consistent with all your units. All right, next slide, please. Okay, so how do you start? By the way, I love Star Wars, so that's just like a little memo in there. So if you're lost, the number one thing you need to do is determine the variable that you're trying to solve for. Number one thing, you can always get somewhere if you go there. Then you want to refer to your equation sheet and find the equation that you can use in order to solve for that missing variable, right? And then once you identify your equation, then you can see, okay, I need to find acceleration, so I need mass and force. So now how are you going to find mass and force? So now you need the equipment to find mass and force. So I would use a force probe or a spring scale and then a balance. And then write out each step again with a verb. So say like what? Place the mass over here, record the time. And then again, please end your procedures with repeat the steps above to determine either the average value, changing some distance, whatever. All right. Next slide, please. Okay, so here we're doing a little rapid fire round with the AP Physics 1 version. Next slide, please. Rapid fire is like 2 questions, by the way. So, okay, so I'm going to name a type of physics concept, and I want you to first type the equation that you're going to need to use, and then type in all the needed equipment that you need in order to solve this experiment. So no, there can be more than one right answer. I'm just going to list a few. You guys might have some difference, but next transition, please. All right, so the experiment is that you wanted to determine whether conservation of momentum has been conserved between 2 carts that collide with each other. So again, tell me in the chat right now, what equation will you use to solve this, and what equipment will you use in order to solve this experiment? No, yeah, same. I literally just like watched all the Star Wars ones like a long time ago. Nice, nice. I'm seeing some good ones. Remember, it's 2 cars that collide with each other. So it's not like you're not finding the change in momentum between one cart. You're finding like whether conservation of momentum has been conserved. Yeah. Okay. Nice. Yeah, exactly. Okay. I'm just gonna do this quick because we're kind of like low on time. So next transition, please. Okay, yeah, exactly. So you're gonna be using some of you said change the momentum. I guess you could use that, but you're gonna have to use your initial equation anyway. But yeah, your balance, your scale to determine mass, photo gates, motion detectors, they're preferred actually for collisions. Stopwatch, meter stick, even if you want to just calculate the velocity and time. All of them work. Again, if you can explain them, you're fine. All right, next transition, please. All right, so now your experiment is that a cart is launched up a hill. Design an experiment to determine the acceleration of the object. Rapid fire, so like max, I'm gonna give you guys 60 seconds. In the meantime, let me see if I missed any questions. Do you need to calculate the actual cart? Well, I mean, you don't need to. You're just calculating like the acceleration of the cart that it's going. Okay. I see like Okay, no. You cannot use the accelerometer because, like I said, that's very rare. That's only if your velocity is changing like rapidly. Like I'm talking about like sine waves type rapidly. No, not sorry, sine waves. That's still simple harmonic motion. Like it's just like irregular. So you're barely ever gonna see an accelerometer on your AP Physics 1 exam. That's only for like the very, very intense cases. All right, let's pull up the next transition. So yeah, it honestly depends what kind of kinematic equation you're using, whether you're measuring for distance, for time, but essentially you are going to use one of the kinematics equations. And then again, stopwatch, meter stick, photo gate, motion detector, anything works. I saw some people use F equals ma. That's actually pretty interesting. You can do that if you use a force probe and then use a mass. So yeah, that's pretty good. I like that. All right, are you guys ready for the experimental FRQ? All right, let's do the experimental FRQ. Okay, next slide, please. Okay, let's go for it. I don't think, let me refresh the slides because that should not be the experimental one. Here we go. All right, here we go. Okay, so here I think let's move on to the next slide because we still have this information. I will show you guys part A. Okay, yeah. So again, it's a lot of information, just like digest it all. I'll give you guys like some time to do this. But this is part A for the experimental FRQ. The screen is a little bit minimized right now. Okay. Oh wait, really? That's funny. Oh wait, okay, that's nice. Yeah, it's a pretty I wanted to do an energy kind of experimental FRQ because it's like a little bit better than the acceleration and time ones. But if you've already done it, I think you can try to see if you can come up with like a new experiment in like a different way because there's several different answers that you could have. Oh, and for the diagrams, I think like some people do like to draw. Like I have this one really artistic friend, who's not as artistic as my skills, but like she's pretty good at drawing. So she drew like the entire photo gate, and she knew how to like write that out. But you can either do the procedure or you can draw. Either one works. I would prefer the procedure. Yeah, we're just a little short on time, so I saw some people give some answers, so just let me know when you guys need more time or how it's going. Are there any really important? Oh yeah, I sent a link by the way earlier in the chat. I can add that, but it has like a really good guide on any. I'm against memorizing, but any like good equations that are like good to keep in mind. Yeah. Oh, thank you, Bryce. All right, I think we can move on now. Oh yeah, I mean, I think it might be something similar. Either it's usually like the experimentals are like velocity, time, energy, or momentum. I've barely seen any like torque ones. Okay, yeah, so you guys are right. A lot of you, again, this is just a sample answer from AP Classroom. But one way how they do this is you can use a mass of a block, distance, and time, kind of like the basic way. But again, measure the mass of the block, starting, hold the block, release it, start the stopwatch, calculate the time, get the velocity. You guys know the drill. And just the interesting thing that I saw of what they did is that for number 6, they actually repeated steps 3 to 5 to get 3 separate trials for starting distance D. And then 7, they say, okay, then repeat all your steps for different starting distances. So if you come across that scenario, you do want to specify what you're repeating and how many times, because this is really, really important that they're going to look for, is that you are showing that you're repeating. My battery's low. That you're repeating from you're finding the average value for like the first set of the trial, and then you're repeating it again to when you're changing your variables. You don't necessarily, I think since this is an experimental FRQ, you do want to say that you're measuring mass, because like per calculations, yeah, they're canceling out, but they don't know that, so you don't show how to do the calculations. But yeah, see, you got like 1, 2, 3, 4, 5 points, bam, if you like do everything like that. So it's pretty doable. All right, next slide. You said height instead of distance. I would think so, yeah, because it's not, unless if like the variable is specified, I think it's open to interpretation. Yeah, so all right, second part, explain how the students could determine the kinetic energy of the block immediately before it reaches the floor using the quantities you indicated in your table in part A. Oh, that's valid, yeah. If you don't know how to explain formulas, just use the equipment that will best help you get to those formulas. Yes, you do derive an equation for this. Can I go back to the slide for 1 second? Yeah, sure. Can we go back 1 slide? All right, let me know how long you want to keep it up. I told you, like, the memes are going to be coming. I had a little fun. Okay, can I go on to the next slide? All right, yeah, perfect. Wait, don't steal like the spotlight of like the no, exactly. It will come, it will come. Unless if you're dying for rotational kinetic energy, then it can come soon. Yeah, yeah. It's only the block for now. You wouldn't lose points, but if something's like unnecessary and it's not really used to calculate a variable that you are using in your equation, then yeah, it will be counted. It won't be counted. It will be counted against you in that sense. But you do just want, if you're using a lot of materials, either like tone it down a bit and see like if you can use a different equation, or just make sure you're like clearly explaining how they're all going to contribute. Yes, there would still be potential energy that you're asking for. Right, can I move on or do you guys need more time? Sorry, I'm just like plugging in my charger. All right. Next slide, please. Yeah, usually, I mean, if it's momentum or energy, I think you guys should be fine. Yeah, for this one, you're essentially just relating, you're just showing that you want to calculate your mass and velocity. And the thing is, so the one thing you should note is that if any of you said like stopwatch or meter stick, then yes, okay. So if you're using a stopwatch or a meter stick, remember the formula is that you're not finding the instantaneous velocity right before that ball hits the ground, but you're finding that average velocity over the time elapsed. So what you will have to do, since you're using a stopwatch and a timer, you will have to use that handy equation that says that v final is equal to well, you remember, if you know that one of the equations, the kinematics, if I remember it correctly, it's like v average is equal to 1/2 times the initial plus the final velocity. So if you turn that around, then you know that your final velocity is equal to 2 times the average velocity. So you will have to show that you are understanding that calculation. And if you're using a photo gate, like some of you said, rotational kinetic energy will come later. Don't we'll get to it. Yeah, so if you're using a photo gate, then you would actually just calculate the instantaneous velocity just before the block hits, so you don't need to do that average velocity thing. Okay, next slide, please. Seems you guys are doing pretty good with this. All right, so part C is this. Again, read it really quickly. Again, there's a graph, so we're just going to introduce all that right now. Well, yes, that is okay, but you do want to just specify that the velocity, like the question's asking that what, like, you're going to find that velocity to calculate the kinetic energy that's transferred. So yes, in this scenario, all the potential energy is transferred into kinetic energy. So you can like say that that's like an extra step, but not necessarily required. Okay, we're a little short on time, so I do want to get to like the final Q&A and everything. And if we don't get to all the information, we actually put a lot of MCQ that are on the slide. So if you guys look on the slideshow and our Cram Hub, there's a lot of MCQs out there and some FRQs that we haven't done yet. So if you want to just like take a few moments and just look over them or do one of them before you sleep for tonight, go for it. And we also dropped the link for the AP Physics 1 Night 5 survey. So once this session ends, please go do that. So it will help us learn how we could improve the sessions for later. The slideshow is in the Cram Hub. I can link that really quickly. So it contains all the slides that we've looked at so far, all the review packets. But yeah, we do have a lot of good MCQs down there in the Night 5 slideshow. So take a look at that especially. Yes, Stephen will be putting on the slides really quickly for that. I can go back one slide, yes. And unfortunately, I don't think we can make it on edit mode just because we don't want everyone on the slide, so like some stuff gets deleted or not. So we will keep it on view only. But if you want, you could make a copy and edit from there. All right, can I move on? Yes, I'll review. All right, so next slide. Okay, so the first, for this part, you're essentially remember that when now, since the rotational kinetic energy is introduced, remember that your total potential energy is equal to both the rotational kinetic energy and the translational kinetic energy. So essentially, if you think about it, rotational energy is like friction because it removes from the it removes from your translational kinetic energy. So essentially, rotational kinetic energy is still positive because energy is kinetic energy is positive and you're gaining in rotational kinetic energy. But number one thing you just have to make sure in this graph is that the values that you add up in your kinetic and rotational energy have to add up to that negative or the opposite of your potential. So if you can see on the very far side, there's like what potential energy goes to negative 0.4 joules. So, and then your kinetic energy is given that it's about like 0.15, I would say. So therefore, you would have to show that your rotational kinetic energy is 0.25. So then if you add them together, it's going to be 0.4 energy. Essentially, you're just going to get 2 points. Again, you want to show that you know the scoring guidelines. You want to make sure that at any point of the graph, your total energy is 0. All right, next slide, please. We'll do this really quick, and then we'll go on to the Q&A. All right, so here we're going to go like speedy quick, 2 minutes max. So the students also measure the angular velocity. Here's the rotation, and then this is just do part 1 and part 2, and then we'll go on. And the night 5 slides should be on the Cram Hub now. So if you guys take a look at that, it should be there. All our FRQs and MCQs are all on there. And you guys can enjoy the memes for longer too. So well, it's not curved because it says draw a straight line. So you can assume that they're making you think that it's a linear relationship. If you just check in that graph over here, we're measuring the x-axis is omega squared and the y-axis is joules. So think about how those are related and what value you will have to calculate in order to get the experimental value for the rotational inertia. So again, look in your equations sheet, think about the equations, and then look at the best thing whenever you're dealing with these is literally make an equation that's y equals mx plus b just by unit. So you know, okay, I have joules here, I have omega squared here. What values are missing in there that could make up my slope or my y-intercept, and how can I find the experimental value? The experimental value is the value that you're calculating by the experiment. So here, they're determining the rotational inertia of the wheel through the experiment. Yes, adjust the best fit line, and then part D, calculate that value. These are like pretty, like if you know how to do them, you can rack up a lot of points really easily. Okay, I'll give it 1 minute max more just so we could do the Q&A. Let me know when you guys are done. Yeah. Okay, I am going to move on just for time's sake. You guys can look at it on the slides later. So for part 1, again, you're just drawing a straight line here. Again, use a ruler for any points and make sure, again, for a good sync, for like a good practice, the amount of dots below and under are roughly the same. All right, next part. Okay, so here, this was like a part some of you guys are a little confused on. But essentially, if you think about, we're calculating rotational kinetic energy, right? That is our Y value. So what equation can you use for rotational kinetic energy? And that's K is equal to 1/2 I omega squared. So it's pretty straightforward here, that you could see that your Y value is joules, your X value is omega squared. So your slope will equal to 1/2 times your omega, 1/2 rotational inertia. So therefore, you always want to just like think about it in the Y equals mx formula, and then your rotational inertia will be 2 times your slope. So therefore, if you calculate that value, you'd get 0.0534 kilograms per meter squared. And note, the College Board knows that you're going to be, based upon your best fit line, you're going to be calculating values that are different. So there's actually usually like a, I would say 0.10 plus or minus difference. So that is that. All right, so that is we're gonna wrap up with the Q&A. So I guess I'm gonna ask all my Cram hosts just to come on so we could look over any of the final advice. Oh, Juliana, I think if you want, you could go to the final advice page so we could do like both together. But yeah. All right. All right, so we can just go one by one and just look at some Q&A, see if we want to answer them. If not, we'll just wrap up with some final advice. Okay. If we are worried about the time in the multiple choice section, do you have any tips to try and make the best out of our time if we tend to be a bit slower at solving the problems? Do any of you guys have any tips to answer first? Oh, Zeke, you're muted.
You're muted, Zeke.
Can you hear me now? Okay, I would say the biggest tip I have for that is go through your exam booklet and answer the ones that you feel confident about first. You might think that it won't really help you out in the end, but in reality, if you do that and you actually solve ones that you're confident about, you can take more time on the ones that you're unsure about, and you might already have like an average of a 3 score on the exam. Versus if you're spending your time getting stuck on ones and you take 5 minutes on one and you only have an hour and 10 minutes or whatever they give you, I don't remember. Now you have a lot less time to solve ones that you might have done in like 30 seconds.
Yeah, exactly. I think like you have what, 90 minutes for 50 questions. Don't spend like a minute, and especially in the first round you go, don't spend more than like a minute and a half on each question. If it's taking long, just skip it and come back to it, because you're in reality, it's much better to get like 4 questions right that you can solve rather than like you're stuck on one question that you can't solve. All right, next question. What are the main things we should know for gravitation? Do any of you want to take it on first?
I mean, I guess the difference between just like the universal gravitation equation and like the one that we use, like the MCQ one that we use like just on planet Earth, and also like gravitational energy. And of course, you need to know how centripetal acceleration plays a part in orbits. And also remember that the mass of the orbiting or falling object doesn't matter at all for acceleration, but it does matter for force.
Yeah.
So everyone make sure to answer the survey that's linked on the Crowdcast, please.
Okay, this question says, do you have to give exact instructions on how to place motion sensors, or can you just say to use it to find the velocity at the time? I would just say you don't need to say like, oh, the laser will calculate the time. Just make sure that you're saying that, oh, I'm using 2 photo gates and they're both going to be placed here, and the card's going to go through one of them, cue the time, and then the other one will calculate the time elapsed, and that's how I'm going to find the velocity. So just make sure you talk about the setup more than like the calculations. Do you have any advice on how to solve questions that compare the gravity on Earth versus other planets?
Well, the gravity on Earth, we all know it's always going to be negative 9.8 meters per second squared for the acceleration. And usually if it's talking about the gravity on other planets, it's going to give you a value. And if not, you're going to have to solve for it. So really it's just being able to plug in the information correctly and recognizing like what's the correct acceleration. It's on another planet, it's not going to be negative 9.8, it's going to be something else. So it's making sure that you really just read the problem carefully and really analyze it.
All right, I guess like for what is a fast method to tell which equations to use? Do any of you guys want to take that out?
I guess really it's just trying to determine what unit it's from. If you can do that, it slims down your options quite a bit. As long as you like know the equations. This goes back to not relying on your formula sheet, because if you rely on your formula sheet, it's going to be real hard for you to pick out what to use. That's all I'm going to say. And also another thing is like you're given one kinematics equation on your formula sheet. You're not given the kinematics equations that tell you, which one's missing, what to use. So those are things that you need to go over to make sure you can actually use it. Because I know for me, I was not trying to derive all that on my tests.
Yeah, exactly. I agree. I think again, you shouldn't blindly rely on the equation sheet. But the first thing you want to do is when you read the problem, just like circle like the I said velocity, like just circle the quantities that you are given, and then just try to like look on your equation sheet. Oh, that okay. Which equations have like work there? Which equations have velocity? Which equations have acceleration? And then just use those specific equations and zero down on, okay, can I use the information I have in the problem in order to find in order to use one of these equations, because you will be using one equation or the other. Okay, can you go over the different physics equations you'll need to know for the FRQ? Anyone want to put that up?
If we did that, it would take all night. So my biggest advice for you is think about stuff that commonly pops up on there. So that's going to be conservation of energy. If it's simple harmonic motion, it's typically going to be a graph that's showing the period of something. Momentum, you just need to know some common ones like that. You don't need to know every single equation. There's some that are on your equation sheet that will be exactly what you will use. The ones that are not exactly the ones you will use from your equation sheet are the ones that you should be going over. And also, if you have some time tonight, some time before the exam tomorrow, look at past FRQs, see what they typically ask for, and you can go based off of that.
Okay, I'm gonna do like one or two more FRQs, and MCQs. Well, one or two more like questions, and then I guess we each of one of us can just go around and say any final advice we have. But can you go over how to tell the difference between open and closed systems in different situations?
Yeah, sure. I can go over this for momentum. So remember for momentum, in an open system, momentum is not conserved, and in a closed system, momentum is conserved. And in a inelastic collision, for inelastic collision, kinetic energy is not conserved, and an elastic collision, kinetic energy is conserved. But does anybody want to go over open and closed system for any other units?
In open systems, like everything, all the energy, all the mass, it's all gonna be like exchanged, and it's all going to be, like everything is gonna be combined onto like the objects that we're talking about. But in a closed system, it's just gonna be like one energy source, or like one and like one mass or one object. It's only gonna be the things that are mentioned really, rather than in an entire open system everything is going to be included. That's how I think of it.
I guess one more thing I would want to add to that, it's pretty typical of like energy, especially. Closed system, your energy will be conserved, but remember, if you have like a spring and an object sliding on a table, if there is a force due to friction, your total mechanical energy will decrease because it's being like exerted out of that system in some other way. But you're not going to be tested on like thermal energy and things like that. You're only tested on the basics, so spring potential, gravitational potential, and kinetic energy. So just remember that if there's friction and you're still in a closed system, your total mechanical energy will decrease.
All right, last one. What is frictional torque? Because someone had an experimental question asking to calculate it. I think I don't know if Juliana, any one of you guys want to answer, but I don't know if I've seen frictional torque before.
I mean, it might be involved in like wheels rolling without slipping questions.
Yeah.
So instead of resisting sliding motion, it would create a force that helps the wheel like roll and move forward. But I haven't really seen any problems tasks for that.
Yeah. That's what I agree. Okay. I think that we have 2 minutes left, so I do want to like, if one of you guys want to say like any final advice for the exam for our wonderful Cram students.
I would say try to write every step that comes to your head when you are writing down an FRQ, especially if it's calculative, because it's quicker than like writing it if it's like qualitative type of question that you have to write a paragraph for. But because like we've seen a couple of rubrics, like they just be giving points for like the weirdest stuff. So if you just write everything, not everything, but like most of the things, your thought process, then you have a better chance of getting those FRQ points.
Another thing is, guys, is like get a lot of sleep, because there's not going to be much benefit if you guys are going to like stay up and stress yourself out. So make sure you guys get a lot of sleep and eat something that's really heart healthy right before the exam, so you guys can have full brain energy on, and you guys are going to do great.
I guess one thing
Go ahead, Z.
I was going to say one thing I would also add is I feel like a lot of times what I've seen with like other students in physics is they really like overcomplicate things, right? So I would just say go with your gut and do not change your answer unless you are 100% positive that what you put is incorrect.
Okay, so as Anastasia said, if you live in Eastern time, it's 10 p.m. And right after this, you should be going to bed, like right away, so you get a good night's sleep. And then for the test, pretty much all MCQ questions do come with units. So those units are your friend. They point out like what sort of variable you are looking for. And if you look at for them on the equation sheet and remember which units go with which variables, it makes it a lot easier to find out which equation to use.
Yeah, I agree. I think just to add on, really like just make sure that I guess for the, if you can, like if you're doing like a math MCQ and it takes some time, just skip it, do a theoretical one, do something that best fits you. Go in the FRQ order of easiest to hardest. If you're not able to like work on something, just go on something that's easy that you can solve and then come back to it because you don't want to lose any points just because you don't have time for it. And I guess with that, we can move on to our final slide, which is just saying us goodbye. We had a lot of fun with you guys this over the 5 days. I feel like we have like a little community now, and we really hope that you guys got a lot out of these crams. And we want to say good luck for all your hard work. All right, see you guys. Good night and good luck.
Good
Bye,
luck,
guys.
everyone.
Bye.
Thank you guys.